Good evening. My name is Austin Becker, and this is Mammalogy News. Mammals are found all over the world in a variety of different shapes and sizes. But one question is asked: how did they get to where they are today? I have gathered 7 different experts to go over mammalogy evolution and how they're able to get to where they were at today. My first expert is Amanda, who will be discussing the Paleozoic era. Amanda, take it away.
Thanks, Austin. I'm here today to tell you about the Zoic era that took place between 540 and 250 million years ago. And this era is comprised of 6 different periods. The first period is the Cambrian, which took place between 540 and 485 million years ago. And back then, the Earth looked completely different than it does today. First of all the land masses were combined together into one supercontinent called Rodinia. And during this period, Rodinia split apart into one supercontinent called Gondwana and many other smaller land masses. And the land masses comprised of Gondwana will eventually make the modern day southern hemisphere continents, and all the smaller land masses will make all the other modern day continents. And this period is also known as the Cambrian explosion, because this is when we first see the diversity of life forms due to the fact that multicellular life began to evolve. And the second period is the Ordovician period, which took place between 485 and 444 million years ago. And during this period, Gondwana moves further south, and all the smaller land masses move closer together. And during this period, at 480 million years ago, we see the first evidence of vertebrae. And the third period is the Silurian period, which took place between 440 and 419 million years ago. This is when the jawless fishes ruled the sea, and we also see the first evidence of life on land due to the fact that planes started to evolve. We also see that the smaller land masses continue to move closer and closer together. And the fourth period is the Devian period, which took place between 419 and 359 million years ago. And this was when all the smaller continents finally collided all together and formed the great continent of Laurasia. And we also see the beginning evolution of trees on land. And at 375 million years ago, we see that the aquatic vertebrates began to transition to become terrestrial vertebrates. And we see this great accomplishment in the fossils that we found of the Tiktaalik. And at 363 million years ago, we see evidence of tetrapods finally evolving. And the fifth period is the Carboniferous period, which took place between 359 and 300 million years ago. And at 320 million years ago, we see the formation of the amniotes, which is a very important step, because this is when we see the new terrestrial vertebrates breaking from their amphibious lifestyles due to the fact that they gain the ability to lay eggs on land, breaking their tie to water. We also see that 312 million years ago, that the split between the groups, the Sauropods and the Synapsids, happened. And the sixth period is the Permian period, which took place between 300 and 252 million years ago. And during this time frame, we see that terrestrial vertebrates began to become herbivores due to all the available different plants available on the planet due to their different evolution. We also see the beginning of mammal characteristics in many of these terrestrial life forms. And we also saw the first true dino being identified in this period, which was around 228 million years ago. And during this time, we also see that the great continent of Gondwana and Laurasia collide together and form the great supercontinent of Pangaea. And these are the major facts of Pazoic era. This has been Mammalogy News in Pazoic era. Back to you, Austin.
Thanks, Amanda. Appreciate the information. And I guess you could say that the Tiktaalik got a leg up on its competition. Our next era is the Mesozoic era, where we have 3 experts that will be going over different aspects of the Mesozoic. Cole will be going over the Jurassic. Cole, take it away.
Here we are at the first period of the Mesozoic, the Triassic, which occurred roughly 250 to 200 million years ago. It is in this period in which we first start to see mammaliforms, which of course give rise to the mammals that we see today. But before getting to that, we must first see what came before. At the start of the Triassic, we were just coming off of the large Permian extinction, which left many environmental niches open. These niches would later be filled by saurapsids and synapsids. Now, synapsids had already split off from the saurapsids, which we see today as extant reptiles and birds and the extinct dinosaurs. And the Triassic was beginning the age of the true dinosaurs, but don't worry, mammals would have their heyday soon to come. A subgroup of the synapsids, the therapsids, had actually survived this mass Permian extinction. Therapsids had already begun to show some mammal-like characteristics. Now, if we look at the therapsid skull, we can see it's began to resemble mammals of today with the presence of a zygomatic arch as well as a sagittal crest for muscle attachment on the outside of the skull, which had not before been seen in the fossil record. They also began to have a much more upright limb posture as well as a deep acetabellum. This would lead to the more varied forms of mammal locomotion that we see today. And from the therapsids came cynodonts, which first appeared in the fossil record around 225 million years ago. Cynodonts had even larger brain cases and were known for their specialized dentition. Their name actually means dog-like teeth. Now, scientists are now predicting that cynodonts had even had a form of lactation. It is important to note that lactation doesn't necessarily mean milk. They didn't have a single localized duct like a teat, but they did have an aggregation of glands. Now, current theory suggests that the original function of lactation was to have the glands rubbed upon non-calcified eggs or even newborns in attempts to moisturize them to prevent water loss. And subsequently, there was likely some degree of nutrient transfer during this process as well, but it wasn't the original intended function. Now, cynodonts came in a variety of sizes and lifestyles. Some were carnivores, others were herbivores, but it was the smaller cynodont species that we believe later gave rise to the mammaliforms. Now, on a side note, it was previously thought that all mammaliforms were small and lifestyle limited, and while that is somewhat true, it is they're less small and less lifestyle limited as previously thought, so just keep that in mind. Now, these are what we call stem mammals, or the super scientific term, almost mammals. Now, they had important characteristics such as lactation and moving away from the lame teeth, but they were still missing a few bits in order to call them true mammals. However, many scientists argue over where the line is drawn between a stem mammal and a crown mammal. The main characteristic that decides whether or not is whether an animal has the presence of a dentary squamosal jaw articulation. That is what gives us our three inner ear bones that were derived from jawbones. Now, it is a hot debate on whether this truly becomes evident in the fossil record. Some say this happens in the late Triassic, others say it happens in the early Jurassic, but it is safe to say that the first true mammal fell somewhere between 225 to 160 million years ago. This has been my report on mammal evolution in the Triassic. Back to Austin for more.
Thank you, Cole. Our next expert is Ebony, who will be going over the Jurassic period. Ebony, please take it away.
Okay. Now we transfer into the dinosaur heyday, which can only be described as the Jurassic. Here we will see some of the biggest terrestrial herbivores, as well as some of the most ferocious carnivores that ever lived. But it wasn't just a big time for our scaly friends. It was also a fantastic time for our mammals. Here we will see the beginnings of our first true mammals. Maybe, probably, within a 225 to 165 million year ballpark. It's close enough. Anyway, these are our fantastic crown mammals, likely evolved from the cynodont ancestor. Now these guys and girls really started to resemble our mammals today, evolved into feed on dentition, mammary glands with nipples, live birth, dentary squamosal jaw articulation, and fur. Although these last two are highly debatable, they could have evolved during the Triassic with a fur sample dating back to 200 million years ago for fossil, and dentary squamosal jaw articulation possibly evolving in the Triassic. We also have our oldest Metatherian fossil surface within dates between the late Jurassic and early Cretaceous. Now, these stem mammals burst in the Jurassic and really begin to radiate at the beginning. These guys likely spread due to the increase in delicious gymnosperms and all of the insects in the Jurassic. Eventually, around the mid to late Jurassic, we see that our stem mammals have evolved into our crown mammals. This is accompanied by the monotremes split in the mid-Jurassic, and possibly even the Metatherian and Eutherian split, although that could debatably be early Cretaceous. Although certainly overshadowed by their scaly dinosaur cousins, not all these mammals stuck to the shadows. Some were as big as coyotes, some were gliders, some were diggers, and some were climbers. There really was a lot more diversity than we originally thought. On a side note, some of our more feathery dinosaurs eventually evolved into birds in the Jurassic, around 160 million years ago. Not the big herbivores, of course, but the smaller, possibly insectivorous critters. This dinosaur age would continue for around 56 million years, accompanied by rising sea levels and continental shifts that began to split up Laurasia and Gondwana, as you can see here. This will eventually open up the Cretaceous period. Back to you, Austin.
Thank you, Ebony. And now Miranda will be talking about the Cretaceous period.
Hi, it's the Cretaceous period. The Cretaceous period brought about drastic environmental change as well as significant mammal radiation where traits that make mammals recognizable start to appear. In the early Cretaceous, about 145 million years ago, mammaliform populations were decreasing. This is most likely due to a massive change in the environment brought about by the Cretaceous terrestrial revolution, also known as the KTR. This took place in about the mid-Cretaceous period, about 125 to 85 million years ago. During this time, there was a global cooling, and ecological diversity dropped due to a large amount of taxonomic turnover. Despite the drop in ecological diversity, angiosperms began to develop and become the dominant fauna, bringing about insects radiation. This opened a door for new niches that mammals quickly began to fill. The first Metatherian fossil is recorded to be found about 110 million years ago during this period, although traits that make up present-day marsupials were yet to be seen. Early Eutherian populations began to give rise as well, although not all were placentals, which also arose during this time about 60 to 160 million years ago. The Metatherian and Eutherian populations thrived under new ecological changes as dinosaur fauna began to disappear and mammal fauna took over. Unfortunately, crown mammals, which gave rise to our present-day monotremes, began to experience population declines that are nearly eliminated during this era. All is going well until...
Thank you. Now that the Mesozoic era is beginning to wrap up, we will be discussing the KPG, one of the big mass extinction events to take place in history. Sam is in the field to talk about this event. Sam, please explain what happened.
Hey, it's time to talk about the KPG/KT mass extinction. This happened roughly 66 million years ago. This is a mass extinction of many species, including the dinosaurs. It is said that this event was caused by an asteroid crashing into the Earth, which caused major loss of life. Of course, with an event at this magnitude, the evolution of species was greatly affected. One model I will discuss is called the long fuse model. This is a model of placental evolution, and it is the most accepted and makes the most sense to me. This model states that modern placentals arose during the Cretaceous. They divided into many of the main lineages, and then these lineages after the KPG greatly diversified.
Now that the KPG has happened, we are transitioning into the Cenozoic era, where Morgan will be discussing the two different portions of the Cenozoic era and all that it entails. Morgan, go ahead.
Thank you, Austin. In the first third of the Cenozoic, the Paleogene time period is where many mammalian orders are finding their way after the effects of the KPG devastation. I spoke with a local, Peter Ungar, who said, quote, "More placental lineages first appeared in the Paleocene than you can shake a stick at," end quote. That's quite a lot, Austin. During this event, Metatherians have been making their way across what is now known as Antarctica to Australia, where they remain successful. As we move into the Eocene epoch, we see this radiation continue to accelerate within the Aphrotherians, while greenhouse conditions stabilize the climate. In this epoch, we also see a significant event in the splitting of Cetartiodactyla into two orders, the Cetacea and the Artiodactyla. From there, we move into the Oligocene epoch, where the climate begins to cool off and seasons develop as the landmass South America splits from the Antarctica while Africa makes the connection with Europe and is no longer isolated. Expansion and radiation of mammals continue, especially in the rodents, carnivorans, and the marine communities. Somewhere in there, monotremes begin to diversify, although only present in a few regions of the world. That wraps up for what I have for the Paleogene time period.
I understand that there's another time frame in this era. Could you please go in depth and maybe explain a little bit more about it?
Thank you, Austin. In tonight's Neogene time period report, we see a peak in mammal diversity mid-Miocene epoch. As grasslands spread, we see an expansion of herbivores and appearance of new forms of placentals, especially the family Bovidae. On the other hand, Metatherians find success only in Australia, Papua New Guinea, South America, and a limited presence in North America. As we move on into the Pliocene epoch, we see the two land masses connect to form the North and South Americas, allowing mammal populations to spread, expand, and interact. With a varying climate, the first deserts appear, while grasslands continue to spread and other habitats become more arid. Finally, we reach the Pleistocene, also known as the Ice Age, where glaciers form in some regions while there is much climate variability elsewhere. In this time, all species of mammals weighing in at 1,000 kilograms or more, and 80% of mammals weighing in between 100 to 1,000 kilograms disappear from all land masses other than Africa. And that wraps up what I have for the Neogene report. Back to you, Austin.
Now that we've discussed the major eras in history, Allie will be giving you a brief summary of each era and a little bit of description about them. Allie, please go ahead.
So to recap what you learned today on Mammalogy Report News, we first went and talked to the Paleozoic era. This is when the world was one big chunk of land called Pangaea. Paleozoic era can be split into 4 periods. In the first one, Ordovician, we first saw vertebrates. Then in the Devonian, Tatalica popped up out of the water and gave rise to tetrapods with their 4 legs. Later on, in the Carboniferous, amniotes came to be, and the amniotes split off into synapsids and cerapsids. The synapsids are the ones that gave rise to the therapsids in the Permian. As a visual, you can see amniotes went to cerapsids and synapsids in the Carboniferous, and then synapsids gave rise to therapsids in the Permian. After the Paleozoic era, we had the Mesozoic era. This is when the world was split into 2 hemispheres, north and south, being Laurasia and Gondwana. We had 3 guest periods, being Triassic, Jurassic, and Cretaceous. Triassic talked about mammal characteristics, true dinosaurs walking the earth, and cynodont with lactation. Jurassic and Jurassic both argued about true mammals with the squamosal dentary articulation and 3 middle ear bones walking their time. But Jurassic definitely had evidence of hair in fossils, live birth, and birds. Then in the Cretaceous, we had the emergence of angiosperms with the KTR, or flowering plants, and fossil evidence of the first Metatherians. With that being said, this means that there was probably some placental diversification, and the placentals during that time could be split into 2 magna orders, the northern hemisphere being Borotheria and the southern hemisphere being Atlodengenata. Both of those could be split into 2. At the end of the Mesozoic era, we had breaking news with the KPG being the extinction of dinosaurs. This brought about a lot of talk of different models about placental emergence and diversification. KPG gave rise to the Cenozoic era that split the world into the 7 continents that we see today. During this time, which can be split into 2 main periods, the Paleogene and the Neogene, a lot of mammal diversification took place as land masses connected or separated from each other. In the Paleogene, Some major events would be Australia and South America splitting from Antarctica, and then Africa being no longer isolated. In the Neogene, we have herbivores increasing in number as grassland area increases. Not too long after, North and South America connect, piquing the curiosity of mammals in that area to travel about. And one of the major events that occurred not too long ago was the Ice Age that made bigger carnivores disappear and led to the evolution of the mammals that we see today. With that being said, I have recapped everything talked about, and I'm going to hand you back to Austin so he can talk about what you should look forward to learning next week on Mammalogy News Report. Thank you.
Thank you. I also want to thank all my experts who came on the show to describe animal evolution. This is Austin Becker for Mammalogy News. Next week, koalas. Normal marsupials or deadly killers. Thank you very much and have a great night.